Hey everybody, we're here today talking about quadratic functions and the factored form. So what is the factored form? Well, we got the factored form right here. It's a quadratic function that's been factored into its two binomials. So take a second and think about what is it that you know about a function that's in factored form. Pause the video and think about that. So one of the things right off the bat is the zeros, right? It's factored, so it tells us, based on the zero product property, right, that whatever value makes each of these binomials 0 makes the entire function 0, right? So those are x-intercepts, right? All right, also called our zeros, right? The other thing that should stand out is the leading coefficient, and this is one of those things that stays the same across all the different forms of the quadratic function, is the leading coefficient. What's the main thing? It tells us the concavity of a function. Okay, it also helps with factoring and all that. And what's the other thing? Well, the y-intercept. Okay, it's not right there, but by plugging in 0, we can see that by multiplying a times n times m, whatever those are, multiplying those three numbers together gives us the value of the y-intercept. Okay, so that's, not too bad. So let's go ahead and take a look at an example. In this case, maybe we don't know how to factor this this expression here, right? It's larger numbers, maybe you don't readily know how to factor it. But what we do know is we have one of the zeros, okay? So we know that since t equals 11 is one of our zeros, t minus 11 will be one of the factors, okay? Now, we're going to use this idea of symmetry that we've talked about over and over. We know the vertex here is at 4 and 784, but what we're really concerned about is how it's 7 units away, right? 7 seconds before and 7 seconds after, right? So if we go 7 seconds before this 4, we're going to get to -3, okay? So that's one way that we can do it, okay? Knowing that when t equals 3, or sorry, t equals -3, that's equivalent to our 0 of t plus 3. Okay, so we have our factors. We also know our leading coefficient, so we could just go ahead and factor this, or write it in factored form as h of t equals -16 times t plus 3 times t minus 11. Okay, so that's one of the options. Once we know the zeros, we can just go ahead and put it in a factored form. We don't necessarily need to know how to factor it. Now we can also factor this one. If we go ahead and factor that -16 out, okay, we end up with x squared minus 8x minus 33. Okay, and if we use the box method or whatever method that you're comfortable with, right, we've got x squared here, -33, so we're looking for the factors of -33 that add up to be -8. And, if we didn't know, it's -11 and +3. So we put those in, we find our common factors. Here's x, -11, +3, and we can see that it factors x plus 3, x minus 11. Okay, just the same, right? So again, we've used the symmetry, not just of the function in general, but the zeros specifically here. Okay, so that leads us to another result here. Okay, how do we relate the vertex to the zeros? We've known everything else from this form. Well, if we have our two zeros, r, m, and n, again, we know that there's this line of symmetry through the vertex, right, at h. There's also this distance that they are away. Okay, so if I go and start at h and I add d, I get to n. Okay, and then if I start at h and I subtract d, I get to m. Now what we'll notice, okay, just like we did in systems of equations, we can add these two equations together. The d's cancel. 2h equals m plus n, and solving for h, we have the average or the midpoint. So that should make complete sense, right? Since our zeros are symmetrical about the vertex, that if we know the two zeros, the coordinate of the vertex should be the midpoint. All right, so let's take a look at how we use this information. So we're going to sketch a graph of this function right here. F of x equals 1/9 times x minus 3 times x plus 3. It's already in factored form. Okay, so what do we know? Well, we know that it's concave up. Okay, so it's going to open up. All right, the zeros, okay, x minus 3 equals 0, and so x equals 3, that's one of our zeros, and then we set x plus 6 equal to 0, so x equals -6 is our other zero, okay, and the last thing that we want to find, okay, before finding the vertex is the y-intercept. So if we go ahead and just plug in 0 here, right, we've got -3 times 6 is -18, and then -18 times 1/9 gives us -2. So our y-intercept is -2. The last thing to find would be our vertex. Okay, we can already start sketching this out. Okay, so we know we got a 0 at 3, and we've got a 0 at -6, and our y-intercept of -2. Okay, now to find the x-coordinate of the vertex, I just plug in. I find the midpoint between the x values of my zeros. So I get -3/2. Okay, so there's -3/2, and my vertex is going to be somewhere down here. Now when I go ahead and plug that in, 1/9 times -3/2, I'm going to go ahead and convert -3 into -6/2. And I'm going to do the same, something similar over here. Make the 6 12/2 so that I can add them quickly. -9/2 here and +9/2 here. One of the ninths cancels with one of the 9s, and we end up with -9/4, okay, which is just under 2. So there's our vertex, and we have a graph. Now mostly we would do a lot of this in our head so we could get an idea of what this thing looks like just by looking at it. Okay, we could plug that into a graphing utility and find the vertex and everything much quicker. So again, we're trying to get an idea of what this thing looks like. So it's concave down, and that's about all I know right now. Okay, I don't know the vertex. I could do -b/2a or various other methods, but let's just go ahead and start factoring. So we'll factor out the -3, and so we have x squared minus 8x plus 12. So again, we want to factor this. We're looking for the factors of +12 that add up to be -8. So it's going to be -6 and -2. So we have x here and x here, -6, -2. So our function is going to factor as -3 times x minus 2 times x minus 6. All right, now that we know that, we know that our zeros are going to be x equals 2 and x equals 6. Okay, setting each of those equal to 0. And then our vertex, the x-coordinate of the vertex, h equals 6 plus 2 over 2, right? That's going to be 8/2 or 4. Okay, so now I can plug 4 into my function here. So 4 minus 2 is going to be 2. 4 minus 6 is -2. So we have 2 times -2 is -4 times -3. G of 4 is going to be +12. Okay, so there's our vertex. The only other thing we need to do is figure out what is our y-intercept to fill this out. Okay, so we plug in 0. So -3 times -2 is positive 6. And then positive 6 times negative 6 is negative 36. So there we go. We have everything we need in order to get a decent graph of this. Okay, so the y-intercept is down here at negative 36. The two zeros are at 2 and 6. And our vertex is at 4, 12. And putting all that together gives us, again, a decent graph. So that's factored form. Try that out. Look at the practice and come to Zoom.